Hey, this is Mr. Yu. Today we're going to do a review on the lesson that was taught in class today, and also we're going to be learning about the sun. So let's get started. So in class we learned about these two different theories of how our solar system works. The first theory is called geocentric theory, and the second one is called heliocentric theory. So the geocentric theory of our solar system says that our solar system, including the sun, revolves around the Earth. So in this theory, the Earth is the center of our solar system. In the heliocentric theory, it says that the sun is the center of our solar system and all the planets revolve around it. So now we know that this geocentric theory of how our solar system works is not correct, and the heliocentric theory is the theory that we accept nowadays in science. So let's talk about how people moved away from the geocentric theory into the heliocentric theory of how our solar system works. There was a couple of guys that helped develop this theory, so let's take a look at who these guys are and how they did it. So the first astronomer that helped develop this theory was a guy by the name of Nicholas Copernicus. He was a Polish astronomer, and he basically worked out the arrangement of the planets that were known at the time, and he figured out that these planets were actually spinning around the sun rather than revolving around the Earth. So before Copernicus came along and came up with this claim, everybody thought all the different planets were actually revolving around the Earth. So shortly after Copernicus, this Italian scientist by the name of Galileo Galilei came onto the scene. He started using these newly invented scientific tools known as the telescope to observe a few things that helped substantiate the heliocentric model of the solar system. So let's talk about those two things. The first thing he noticed was that the moons of Jupiter were revolving around Jupiter, and this proved that not everything in our solar system was revolving around Earth. He also made another discovery, and this discovery was that he noticed that the planet Venus had phases, kind of like how the moon on Earth has phases. And using some math and some logic, he was able to prove that Venus was actually revolving around the sun as well. So Copernicus and Galileo kind of brought the whole world out of this geocentric view of the solar system into this heliocentric view of the solar system. And eventually this caused a big scientific revolution in the way people thought about our solar system and the universe itself. Alright, so I want to talk to you guys about one more scientist before we get to the other topics. And this last scientist's name was Johannes Kepler. Now, Kepler came up with these three laws on how our solar system works. So I'll just run through these laws, and we can talk about them as we go through them. Okay, so Kepler's first law says that the orbits of the planets don't go in a perfect circle. They actually go in a shape that looks like this, and the shape is called ellipse. So this shape is called an ellipse, and Kepler's first law says that our planets go in, or they orbit in an ellipse. Kepler's second law says that that as planets get closer to the sun, that they speed up during their rotation. So as this planet Mercury gets closer to the sun, it's going to start speeding up, and as it starts moving away from the sun, it's going to start slowing down a little bit. And this is due to the effects of gravity. Alright, you don't have to know the exact reasons for this because it's a little bit advanced and it takes a little bit of math to figure out. But just know that Kepler's first law says that planets orbit in an ellipse. Kepler's second law says that planets move faster as they get closer to the sun. So Kepler's third law basically says that the average distance from the sun and the speed at which the planet orbits the sun are related. He found that planets that are closer to the sun orbit the sun faster than the planets that are further away from the sun. So those are Kepler's laws. So why don't we go to talk about astronomical units. So astronomical units is a unit of measurement that we use to measure the distances between celestial objects. So 1 AU is the distance or the average distance between our Earth and the Sun, and it's approximately 150 million kilometers. So let's talk about another important distance that we use to talk about celestial objects. This distance is called light years, and light years are what we use to measure really long distances. So basically how it works is the amount of distance light can travel in 1 year is equal to 1 light year. So I'll give you a few examples. Our solar system is somewhere around here, and then our nearest sun to our sun is approximately 4 light years away. Another example. So this is our this is the Milky Way galaxy, and the diameter of our galaxy is approximately 100,000 light years. So if you were to take a flashlight or a laser and just point it into space and just wait and count how long it would take the light to get across this galaxy, it would take 100,000 years to get across. Alright, now that we know about light years and astronomical units, I want to talk to you guys about a few other things and then we're going to be done. The first thing I want to talk to you about is the sun. The sun is the only source of light and heat in our solar system. It's the thing that provides us with all the light and all the heat in our solar system. And our solar system comprises of these 4 inner planets and these 4 outer planets. The way that you guys should remember this is by this acronym. My very educated mother just served us nachos. So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. My very educated mother just served us nachos. It's pretty easy. It shouldn't take you that long to memorize it with this acronym here. So I'll talk to you guys quickly about the inner planets and then the outer planets, and then we'll be done with this video. The inner planets are the 4 planets that are closest to the sun. So Mercury, Venus, Earth, and Mars. And the inner planets are defined by their terrestrial qualities. So they're usually rocky surfaces. So all these planets are solid and they're rocky surfaces, just like the Earth. And the outer planets are the 4 planets that are further away from the sun. So Jupiter, Saturn, Uranus, and Neptune. So these 4 planets are called the outer planets, and we also call them gas giants because what you see on the surface of these planets are gases. And at the core there's a tiny, not tiny, but relatively smaller, hard surface, but on the outside most of what you see is going to be your gases. So that's our video for today. I hope you guys enjoy that. I'll talk to you guys tomorrow. Bye bye.